clues in your ear.
Good morning, everyone. How did the homework go, the practice problems? Did you guys work on them?
The one for point 10 or the online one?
Put them on chat so I have them written down. Can you put them on chat?
Sorry, 1 second. I have to take care of something.
Okay. That's fair.
My dog is being unruly.
All right. Okay, so okay, it's 9:30, so you're fine. So as while your classmate is taking care of something, so what?
I just had to let my dog outside.
Oh, that's okay. That's all right. No problem.
I was asking if you were talking about like the problems you put on in like the module or the problems that
The
were
practice
on
problem. In class, we do the practice problem.
All right.
And some of them are the same. It's just changing number. And some on Moodle or the online are slightly harder. So I can discuss them with you probably at the end of the class if anybody wants to. Okay, so as I said, while your classmate is finding those problems that he's interested in, and all of you would be as well, I need to talk about the quiz for 1 second. As you guys, I graded the quiz, and please read the comments I put on your quiz. Otherwise, it's useless. I mean, if you don't read the comment, understand them, it's really like you don't learn from them at all. And the goal from the quizzes is actually to learn from them. So problem number 1 is the one that stood out as usual, and you guys had difficulties with it. Some of you, not all of you, of course. I read it, and again, we try to kind of understand it. As dry air moves upward, it cools. So when the air goes up, it cools. It means the temperature goes down. And let F be the following function. It is sinus to each height T in kilometer above ground level. So it assigns to the height the temperature of the air in degrees Celsius at this height. So what does my function do? Whenever you really have a problem, try to picture what the function do. It assigns what to what. So this function does the following. It assigns to the height, means if you give it height, the function will give you the temperature at this height. That's what it is. So you give it the height, that's your input. And what the temperature assigns to the height, the temperature at this height. So my input here, it means what you are going to give it. So the input here is basically the height. And the output, what it's gonna spits out, so that's a machine. You give it and is the temperature at this height. Okay. So I told you that make a sketch of the graph of F and make sure to label your axis carefully. And that's really where the difficulty came. Remember, always we put the input value on the horizontal axis. It means on the horizontal axis, R is the height. A lot of you put the temperature. The height goes on the vertical axis. Sorry, on the horizontal axis. And on the vertical axis, the temperature in degrees Celsius. So the height in kilometer on the horizontal and the temperature here. Now the question is, make a sketch. And that was very clear. I told you, I don't want you to pick up value, but basically what I want is this function increasing or decreasing. So what do you think? Increasing or decreasing? I get back to you. I want you to think. What does it mean increasing? Increasing means when the input means the height increase, does the output gain value? Decrease mean when the input increase, the output loses value. So is it increasing or decreasing? Who would like to discuss it with me?
Is it decreasing?
Because. You correct, because.
Because as the air moves up, it cools.
Meaning, air moves up, it means when the height increases. What happened to the temperature?
It decreases.
It goes down. That's really the picture. So when you are sketching those values of the temperature as a function of the height, as the height is going to increase, the temperature is going down and down and down. So the graph is a decreasing function. And that's how that's how we do this problem. Okay. So a lot of you lost point right there. Those are important problems to start understanding how the function acts, how is the temperature, how input changes with output. Okay. All right, so this is my main comment on the quiz. The other problems went fine in general. If anybody had any specific question, they can ask me. But this problem kind of stood up for the whole class. All right, so your classmate, I don't know if you found the questions or not. So last time we talked about the average rate of change. So we're going to do some problems with that, and then we move on. Right? Usually I want you to ask questions. I don't want to be the one who is initiating that. Please do the homework. It's the only way you're going to learn this stuff. So the average rate of change, we defined it to be, so the average rate of change of a function between two values is f of b minus f of a. That's really the formula, okay? But we're gonna try to visualize it and understand it, right? So I'm gonna do a few problems from the book and then I proceed. So first we're gonna do a problem which is graphical in nature. So let me pick this problem. So I'm gonna just pick some problems that I assigned and you're gonna do them. So the first problem is, this is the graph of a function. Okay, so this is number one in the book. So we're gonna do number one. Okay. So this is the graph. Question number one is f increasing or decreasing on the interval from -1 to 4. Okay, back to you for every problem. Is the function increasing or decreasing on the interval from -1 to 4? What can you say?
Decreasing.
Okay, so first -1. -1 is here, and this is 4. So the question from here to here, is it increasing or decreasing?
It's decreasing from 0.
So it's decreasing from
0
to
4.
right? But from -1 to 4, what would be your answer? Don't be afraid. Don't be afraid of an answer that makes sense to you.
Technically, wouldn't it not be doing anything? Because it's both
Exactly.
increasing and decreasing.
Exactly. That's what I told you. Don't be afraid. It's neither. It's absolutely neither. Because between -1 and 0, it's going up, it's increasing. Then from 0 to 4, it's decreasing. So is it increasing or decreasing? Your answer should be Neither. Don't be afraid of what you understand. It's absolutely neither. So it's neither increasing nor decreasing on the whole interval. So the answer should be A is neither. Okay, neither because for x between -1 and 0, f is increasing, and for x between 0 and 4, f is decreasing. So it's neither. It's neither, absolutely neither. All right. Question number 2. What is the average rate of change of the function? What's the average rate of change of the function on the interval 1 and 4? Okay, so what's the average rate on the interval 1 and 4? Okay, we're gonna find it and we're gonna try a little bit to visualize it on the picture. So f of 1, to find the average rate, so the average rate is, okay, I'll write it here because it's better for me. So I'm gonna skip a line, I'm gonna put the average rate here. The average rate is, for x between 1 and 4, it's f of 4 minus f of 1 over 4 minus 1. So that's for x between 1 and 4. Okay, so to find the average rate, I need f of 4 and I need f of 1. So what is f of 4 quickly?
Looks like it's at 1.
What?
1.
1 or 0? I don't know.
It's kind of hard to tell.
Okay. It seems to be 0.
Yeah, it does.
Right? It seems to be 0. Okay, so f of 4 is 0. And what is f of 1? Can you guys tell? You should have done the homework. I mean, I insist. That's the last time I do that. What is f of 1?
15.
How much?
15.
4, 8, 12, 13, 14, 15. 15. So the average rate is f of 4 minus 15 divided by 3. It means minus 5. Did we expect to have a negative sign? Back to you. Did we expect a negative sign? Why the average rate is negative? Quickly.
Because it's decreasing on the graph.
Right, because the function is decreasing. Between 1 and 5, the function is decreasing. Okay, and now let us a little bit visualize. So for this problem, I'm going to remind you of the visualization. How did we visualize the numerator and the denominator? So it will be easier for me to draw the graph here, kind of. So that's how my graph looks like. It went up here, and then it started descending there. That's really how my graph looked like. This is 4, and 1 was here. This is 1, and this is the output at 1. Okay, so what is f of 1, f of 4 minus f of 1 on the picture, and what is 4 minus 1? F of 4 minus f of 1 is the following. Between x equal 1, x equal 4, so the output changed. The output was right here, 16. The output went all the way down. So when you're taking this difference, it's from here to here. So this is 16 and this is 0. F of 4 minus f of 1 is right there. It's how much your output changed. That's the delta y, and that's the minus 5. I put the arrow down to express the fact that it's decreasing. So that's your delta y. Where is the 4 minus 1 in the picture? The 4 minus 1 is your input. Went from 1 to 4. So it's changed by 3. And that's your change in x, which is equal to 3. And the average rate is how much your output changed divided by how much your input changed. which is some student rightfully so tell me, isn't this the slope? Yeah, it's the slope of this line, which we're going to talk a little bit more about it today. All right. So that's how we visualize this average. That's the numerator and that's the denominator. Now, the last question will be fairly simple. What's the average rate of change of f on the interval -1, 3? Back to you. Do you think you're going to get a negative value or a positive value for the average rate?
Negative.
Because what did the function do? Did it lose value or gain value between -1 and 3?
Lost value.
Yeah. What is f of -1? What is f of 3? And the average rate of change is the output at 3 minus the output at 1 over 3 minus -1. Be very careful. This is minus -1. So it's going to be equal to, what is each one of them? What is f of 3? Can you guys see it better than me? This is 3. F of 3 is up to here. And f of 3 is up to here. That seems to be a 7. -1 seems to be a 15. So it's going to be 7 minus 15. Be very careful in the denominator. 3 minus -1, 4. It means how much from here to here? That's the delta x. That's what it is. So finally, I will get -8 over 4, which is the -2. So that's how we do this problem graphically. Right. Now I would like to do 2 problems purely, how can I put it, symbolically, which are crucial for us. And then I will do a problem, which is word problem, which is the number 7 in the book. Okay, so symbolically, that you have to know just because calculus uses the symbolism tremendously and we have to learn. So I'm going to pick one problem. I don't know that symbolism is in order. Okay. So I'm going to do number 8, for example. I don't know, number 7, because it's a little bit symbolic, and then another one as well. So I'm going to do number 7. And this is the function, f of x equal x squared plus 7. Okay. And the question is, find the average rate of change. Average rate of change. So for x between 1 and 5. Right. Okay. So that's simple. We have numbers. There is nothing really to be worried about. So what's the average rate of change? It's the value at the function. At the right value minus f of 1 divided by 5 minus 1. Okay. So to find the average rate, I need the output at 5, the output at 1. So let's find them right here. So the output at 5 is 5 squared plus 7, which is going to give me 25. 25 plus 7, which is 32. And f of 1 is 1 plus 7, which is 8. So the average rate of change becomes 32 minus 8 over 4. So 32 minus 8, so you're going to left with 24 over 4, which is equal to 6. Okay, so the first question is simple. You just have to plug in inside the formula. And on the graph, if I gave you the graph of the function, this is f of x equal x squared plus 7. It looks like this. Means if you plot all the points, I get something like that. That's the graph. And what's the average rate? I mean, what is the numerator and what is the denominator on the graph? So if this is 1 and this is 5 right here, this is the value of the function at 1. And this is at 5. So when x go from 1 to 5, your output was here. And it grew. It's all the way here. So from here to here, the change, that's the change of output. This is the f of 5 minus f of 1. That's the f of 5 because this is f of 1 right there. That's your 8. And let me take a red pen. And that's f of 5. It's right there. So you're taking the difference, f of 5 minus f of 1, you're basically telling me how much your output changed. And 5 minus 1 is here. It's how much your input have changed. And it's the ratio, change of output over the change in input. That's the picture for this problem. Now, we're going to pick, I will pick, for example, number D. Or actually, I will take C because it's now symbolic. C is the following. Find the average rate of change for x between 3 and t. Okay, so I don't want you to be worried from those. So we're going to do that. So what's the average rate? Yes. The value at t minus the output at 3 divided by t minus 3. Okay, so it's equal to what? All right, let's compute each expression by itself on the side. What is f of t? Back to you. Okay. I'm going to start picking student. What is f of t? Okay, I'm going to pick one of you arbitrarily, as you know. I don't really know you. Xavier, what's f of t? Are you with me?
Yeah.
Okay, what is f of t?
Well, the
You
way you
mentioned
set
it
it up,
on the homework. You should do the homework. Keep going.
the way you set it up is t squared plus 7.
T squared plus 7.
Mm-hmm.
What's f of 3?
Is 9 plus 7,
Which
which is
is
16.
16. So what's the average rate? F of t squared plus 7 minus f of 3, 16, divided by t minus 3. So what do we get? T squared over t minus 3, which will give me the following. 7 minus 16 minus 9 divided by t minus 3. Okay? I'm going to do one more. Again, symbolic. So we develop a certain comfort with those. Okay, so I'm still working with D. Average rate of change of F for X between 3 and 3 plus H. Okay, right? So it's going to give me how much? So don't be afraid of H. It's the output at 3 plus H minus the output at 3 divided by 3 plus H minus 3. Okay? So even if you have H, you have T, don't let any of those get into the way. So now let us evaluate each one of them. So I'll do it on the side. So what's of the f of 3 plus H? Now the formula is, whatever you give it, square it and add 7 to it. Whatever you give it, I'm giving it 3 plus H. So fine, this is going to give me 3 plus H times 3 plus H plus 7. It means 9 plus 3H plus 3H plus H squared plus 7. It's going to give me H squared plus 6H plus 15. Okay, that's for f of 3 plus H. Now I need f of 3, but we did it a minute ago. F of 3 was 9 plus 7, which gave me 60. Now I computed the pieces. Now I'm going to plug everything back. So it's this expression, which is H squared plus 6H plus 15 minus f of 3, which is 16. 3 plus H minus 3, the 3 minus 3 cancel each other out. We get an H. So finally, we get equal to H squared plus 6H plus 15 minus 16 divided by H. And why I feel I have a stupid mistake.
I think that 15 is supposed to be a 16.
I fear I have a stupid mistake. Thank you very much. Okay, all right. So now, plus 16 minus 16 do cancel out, which leaving me with that. And then finally what? I can improve on this. Okay, we can do a little bit of algebra. What kind of algebra can we do to make this look a bit nicer? Can anybody pitch in?
Do you take the square root?
No, why would I take the square root? If you take the square root, you change your expression. I don't want to change anything. I'm going to simplify only. So those problems are purely for, I mean, honestly, those problems will come up a lot in calculus. You always compute those ratios. So what we're doing here is kind of preparing you a little bit for this abstraction that you will see later on. So how can we're not changing the expression, we're just simplifying it a little bit. Can anybody think of a way to simplify it? Can anybody see something in common in the numerator and denominator? You don't mean multiply, Ricky, you mean something else. Okay, one thing you can do is, this is H here. We're gonna try to factor out the H. Right, we have somehow, yeah. So we're gonna see, can I factor out the H? It means, can I factor out? Can I write the numerator as H times something? Now we realize that, I mean, the way you can read this actually, H squared is, it's H times H plus 6H. That's really what the numerator is. So I can basically factor out this H, and this would leave me with H plus 6. So now if I multiply it out, I will have H times H plus 6H. The benefit of this mainly is that since H is a common factor in the numerator and the denominator, I can simplify it out because it's a common factor. Otherwise, I won't be able to simplify. So that's really what I mean by simplifying the H. Please do the homework I assign. I don't like to do them without you having been exposed to them before. Please do the homework for the umpteenth times. Okay. So the last one, I would like to look at it before we move on, unless you guys have any specific question. It's the simple one, but it reminds us basically the meaning of the average rate in problems. What we did, a little bit, we did problems like that last time. So I will look at number 6 here in your book, of course. And we have a table. And the table below shows the estimated world population in billion of people. So that tell me the world population in billion of people. And I have a function g that to every year assign the world population. So the input is the year, the output is the world population. And the number they're giving you the website where those numbers are coming from. So in 1804, the world population was 1 billion. 1850, 1.2 billion, and so on and so forth. Okay. So the first question is rather simple. It tells you how long did it take the world population to increase from 1 billion to 2 billion? Quickly. How long did it take for the world population to increase from 1 billion to 2 billion? I'm looking at chat, I don't see answers. So how long did it take? Anybody?
123.
Okay, it's, how did we get that? From 1 to
I
2?
looked at the one that said 1 and the one that said 2.
Okay, from 1927, I meant. From 1804 to 1927, it grew from 1 to 2. It means it took the difference, which is 123 years. Okay, so at the beginning, it took 123 years to grow from 1 to 2 billion. And then the question is, what about from 2 billion to 3 billion? How long it took the population to grow from 2?
That took 33 years.
It's let's see, from which year do you see? From 2 to 3. So from 1927
to 1960.
to 1960. That's how it happened. So it took how long? 1960 minus 1927, which is how much? 33 years. Okay. So this is definitely show how population grew. It took 123 years to grow from 1 to 2 at the beginning. But then it took only 33 to grow from 2 to 3. So the population is changing at a very, very different rate. Absolutely very different rate. So it's changing much faster as we move on, as time goes by. And then finally, from 3 to 2, sorry, from 3 billion to 4 billion. So how much was the population exploding? No, sorry, from 6 to 7, my apology. From 6 to 7 billion. From 6 to 7 billion, from 1999 all the way to 2011. So it took minus 1999. It means it took how long? Who can do the math quickly? 12 years. Okay, so interesting numbers. To grow by 1 billion at the beginning, it took 123 years. In the early 20th century, it took 33 years to increase by 1 billion. Now, basically, it took 12 years to increase by 1 billion. The population is increasing really, really, really fast. And eventually, it has to stop doing this. I will answer now one of those questions. What is the average rate of change over the time period when the population went from 1 to 2? So when the population went from 1 to 2 billion, here, what's the average rate of change? Quickly. What was the average rate of change when the population went from 1 billion to 2 billion? How do you compute that? What should you put in the numerator? No. No. So let us do that on a clean sheet of paper. So the question is, what is, let's do that. B, find the average rate of change of the population when it went from 1 billion all the way to 2 billion. Okay, what do they mean? When did the population go from 1 billion to 2 billion? It means you have to find the average rate of change of the population when between the year 1804 and the year 1927. The input here is time. The output here is the population. So the average rate of population when it went from 1 billion to 2 billion, it means you go up here and you say, okay, from 1 billion to 2 billion, this change occurred between the years 1804 and the year 1927. So the average rate of change is the population, because I'm in 1927, because G represents the population in this problem, minus the population in 1804, divided by the change in time. How fast population is changing in time. So what goes in the numerator is the change in population, which is 1 billion, basically. What goes in the denominator is the change in time, which was 123. All right, so what goes in the numerator is the change in population. What goes in the denominator is the change in time, which is going to give me 1 over 123. All right, so which is a weird number, and you will see in a minute why it is weird. So if I use my calculator, I'm getting 813. Okay, I'm going to drop the rest. What is the unit here? So I'm finding how fast the population is changing. What's going to be the unit? I want you to think a little bit. What's the unit of this one up here? And what's the unit of this here?
Wouldn't it be people a year?
Not quite people. I mean, it is people, but be more precise. Who can change? Who can fix what he said? The one is what? One what? When I take 2 minus 1, this 2 is what? And a billion. Minus a billion. So that's 1 billion. So the population changed 1 billion in 123 years. It means it's 0.008813 billion people per year. It's not people, it's not 0.0, it's 1 billion people per year. Okay, so the unit is the unit of the numerator, which is billion people, per unit of the denominator, which is a year. Okay. So that's how fast the population changing. So that many billion per year. So I will do one more. So the main thing is that here, how average rate of change of population. Now the population is my output. It means you take the change of population, how much it changed, how long it took. When you take the ratio, it tells you, okay, per year, that's how much the population was changing on average. On average. The average is crucial. All right. Now, what was the average rate of change over the period when the population went from 2 to 3? So that's the first one. So when the population went from 2 to 3, so from 2 billion to 3 billion, this occurred between the following time. So from 2 billion to 3 billion, we figured it out a minute ago. It occurred between 1927 and 1960. So how fast was the population changing? Again, the average rate of change is going to be how much the population changed divided by how long it took. So it's the population in 1960 minus the population in 1927 divided by how long it took. In 19, that's 3 billion minus 2 billion over 33. 1 over 33. Means it took 33 years to go increase by 1 billion. So if we do the math now, we get 0.03, sorry, 0.0303 billion per year. And we know that the speed, the population is changing faster. It's 0.008 billion per year, 0.03 billion per year. And that's an average. Means not exactly that much every year, but that's how much it averages per year. So what's the interpretation of the average rate? It means on average, between the year 1927 and 1960, the population was changing by 0.0303 billion per year. That's what the average, it's the speed. When you hear average, think about speed. How fast was your output changing in terms of the But you guys, please ask questions. That's not, I like it when you guys help me, when you guys ask questions, when you guys tell me about a problem you couldn't do. It's not when I do it. Okay. Any questions? All right. So today we're going to move to the following section. 1.11, unless you have any questions, which is I strongly encourage. Okay, lines and linear function. So section 1.11, lines and linear functions. Okay. All right, today we're going to talk about lines. And I know that you guys have seen lines before. I'm not really, I'm fully aware of what you guys have seen, but we have to review them. And we have to review them why? Because they are crucial for you. Okay, so first we're going to study lines, and then we're going to go to use them to understand linear function. First, we're going to just study this aspect. So a line is just a line. So what is a line? Simply is just a line. That's a line. That's when we mean a line. Simple as that. And when things curve, like this is not a line. So this is just not a line, that's a curve. So that's really what we mean by a line. And this is just simply a simple curve. Okay. Now, what characterizes a line is the idea of a slope. So let us remember the slope of a line. Okay. So suppose we have a line, just this picture here. That's a line. And suppose we have 2 points on the line, slope of a line. So suppose we have 2 points. I'm going to call them x1, y1, and x2, y2, 2 points on the line. On the line. So I have 2 points. I'm going to draw them here. So I have 1 point, and I have another point. So that's, I call this x1, y1, and I call this x2, y2. Okay. Then the slope of the line, the slope of the line. So just remind us, of course, the average rate. The slope of the line is equal to. All right, what's the slope of the line? Like we thought of the average rate. Suppose we're going up along this line. Horizontally, we go from x1 to x2. So we're going from this point to that point. Means we move from x1 to x2, and this is y2 minus y1. So this is x1, and this is x2, and this is y1 in the picture, and this is y2. The slope is equal to the following. It's y2 minus y1, the y coordinate minus the change in the y coordinate, divided by x2 minus x1. So in the picture, what is the slope? This is y2, all the way up to here, and this is y1. So y2 minus y1 is nothing more than by going from this point to that point by how much you went up, that we call usually the rise. That means you rose from here to here. By how much you went, this is the y2 minus y1. That sometimes we call it the change in y. And when you went from here to here, x1 to x2, by how much you went, that's what you call the run or delta x, and that's your x2 minus x1 in the picture. And the slope is the ratio between delta y, the change in y, and the change in x, between the rise and the run. So how much you rose going from this point to this point, divided by how much you moved horizontally. So that's really the slope of the line. Okay. Now, what characterizes a line from a curve? What characterizes a line from a different curve? So let me explain a little bit. What's special about a line? What's special about the line is the following. If I take a point on the line, it's a pure geometry, I want you to understand it, and I move a little bit. Suppose I moved 1 unit, that's the run, and then I go up, that's the rise. And if I pick another point on the curve, here, I move 1 unit and I rise. The rise, if I move by the same amount, if the run is the same, those two are usually equal, always equal on a line. That's really what characterizes a line. If I have a curve, this doesn't happen. And I just wanted you to show it in the picture. Suppose I move by 1 unit here. That's how much I rise. If I take another point on the curve and I move also, I run by 1, you can realize that you don't rise by the same amount. That's what characterizes a line from a curve. So if you take delta x to be 1 on the line, the rise is always equal. If once the curve, this doesn't occur. So there is no idea of a slope for the curve. We only talk about the slope of the line, because here you go by 1, that's how much you rise. You go here by 1, you rise by much less. So in this case, the delta y over delta x is actually changing. For the line, the delta y over the delta x is going to be constant. So that's what happened for the line, and that's what happened for the curve. And now we are really focusing on the line where the delta y over delta x actually does not change. Okay, so that's what characterizes a line from a different curve. All right, so let us compute some slope and then proceed. So let us compute some easy slopes. So example number 1. Okay. Find, so part A, find the slope, just the slope now, of the line, joining the point, I'm going to just give any arbitrary point. So joining the point, for example, 1, 4, and 5, 12. Okay, so it means I have a line, and this is a point on the line, 1, 4, and another point, 5, 12. And 12 is right here. And this is the line, these are the 2 points. And we need just the slope. All right, so the slope is pure and simple. The slope is the change in the y, 12 minus 4, divided by change in x, 5 minus 1. So which is going to give me the 8 over 4, nice numbers, which is equal to 2. Very simple. So on the graph is, this is a point, that's the point. I need to go from here to here. And the slope is, so I am at y is 4, y is 8. So the slope is going to be the change in y, that's what we call it, the rise, and that's the 8, and over the change in here, the delta x, and that's really 5 minus 4, and that's the 4 in here. And so that's the delta y, and that's the delta x. And it's just the ratio between them, pure and simple. Okay. So part B, again, find the slope joining the following 2 points. So for example, I'm going to put 1, 4, and let me pick another one. So let me pick, for example, 5 and minus 8, for example. Okay. So let's see what's the slope here. It's basically exactly the average rate of change. I mean, it's the same thing we're doing. So the slope of the line, so 1, 4, that's my point, and 5 minus 8. So that's a 5. Minus 8 should be down here. Okay, and this is my line. And I need the slope. So this is a 4 here, and this is the point minus 8. All right, so what's the slope? The slope is the change in the y's. So it's minus 8 minus 4 divided by the change in x. So if I use 5 minus 8 here, I should choose the x that correspond to this y. And here I use the x that correspond to this 4. So this is going to give me minus 12 over 4, which is minus 3. Okay. And as for the average rate, why do we expect the slope to be negative? Because the line is actually falling for us. So what's happening here? As we go from this point, -4 to 5, my y was 4. And then my y become -8. So that's from here to here. That's what, again, what we're gonna call the rise, even though it's a fall, but we usually the word rise here. So that's the -12. And how much? By moving from 4 to 5, my x changed by 4. So that's the change in x, and that's the change in y. Why it is negative? Because actually the graph is falling. The function is actually decreasing. So the two things about the slope. So positive versus negative slope versus negative slope. Okay. So if we have a line, simple line, when the line rises, the slope positive. If the lines fall, slope is simply negative. Okay, so basic idea about the slope. Before we talk about the equation of a line, I'm going to ask you a simple question. I want to ask you the following. Sketch a line. I want you to do that. Sketch a line that passes through the following point, through the point -1, 3, and with the following slope. A, slope equal to 4. Is it an easy or a hard question I'm asking you? I want you to sketch a line. A line. And the line passes through -1, 3. So that's a point on the line. So this is -1, this is 3. Okay. I want the slope to be 4. So how can I construct the line so the slope is equal to 4? Back to you. So remember, the slope is basically it's the rise over the run, or the change in y over the change in x. So how shall I sketch the line? Am I giving you enough info to sketch the line? What do you think? I give you a minute. Aiden, did you raise your hand?
No.
No, okay. Anybody? So how can I sketch a line that go through this point? So that's a point on the line. I want the slope to be 4. Anybody would like to pitch in?
From that point, can't you go like to the right 1 and then up 4?
Right, because the way I can think about it is, if the run is 1, the rise is 4. It means if I start from here and I go up, the run is 1. To have a slope of 4, I have to go up by 4. So this is 3, 1, 2, 3, 4. So that's 4. And that would be my line. Okay, so if I have a point and I'm giving to the slope, the way you sketch the line, you say, okay, I start at this point. If I go by 1 unit, that's my run. Do I have to go by 4? So we go up 4 on the y-axis, and that will be the line. Okay. Example number 2. Let me change a little bit the point. So that's A, B. Again, we're going to sketch the line that passes through, I pick another point that I say to 6, and with slope -4. Okay, so I'm going to sketch the line. It goes through the point 2, 6. It means if x is 2, I want y to be 6. If this is 6 and this is 2, that's the point on the line. And I want the slope to be -4. So slope is -4. Basically, you can think of this as this should be the rise over the run. So you can think of -4 is divided by 1. All right, how shall I do it? This time, I think you should be ready. I will ask a student arbitrarily. Believe me, I don't know you. And Olivia, can you tell me?
You would just go down 4 and then over 1.
So we can go 1 here, and then we're gonna go 1, 2, 3, 4. So we go down by 4, and then I connect those 2 points. That's the line. Okay, now the slope is definitely, if we go down by 4, it's gonna be -4 over 1. All right. Now the last one along the same line. So C. Sketch the line. That passes, let us say, through the point, okay, 2, 3, and slope 4/5. Okay. So I want the slope to be 4/5. So 2, 3. 1, 2, 3. That's the point. Okay, I want the slope to be 4/5. Who would like to pitch in? Up 4/5. Okay, exactly. We're gonna think of the numerator as the rise and the denominator as the run. It means that if you go by 5 units, so 1, 1, 2, 3, 4, 5. So this is my run if you want, or the change in x. This is the 5. We have to go down by 4. 1, 2, 3, 4. Sorry, my apology. We have to go up by 4. 1, 2, 3, 4. We end up right here. So this is the rise or the change in y. This is the 4. So this is my line. Okay. So simple exercises, but tell us something. This tells me something important. Tells me that if I know a point, and I know the slope, I can draw the line. There is one line that satisfies that. So it means that if I can draw the line, so we can sketch it, it means that I should be able to find a way that if I take any point on the line, if I take any point, I need now a process that if I take any point on the line, if I know the first coordinate, if I know this, the question is, how can I find the second coordinate? So if I can draw the line, I should be able to find a way that if I know the x coordinate of the point, the question is how to find the y coordinate. And this would lead us to the idea of equation of a line. So what do I mean by equation of a line? Before we do that, what does it mean to find the equation of the line? Finding the equation, if you have any line, what does it mean to find the equation? It means the following. Find a formula that if you know the x coordinate of a point on the line, this formula will tell you what is the y coordinate. So finding an equation, it means finding a way so that if I know, take any point on the line, knowing the x, the formula will give you the y of the point, the y coordinate. So that's what it means finding an equation, finding this relation between the x and y coordinate. So that's exactly what we are doing. So equation of a line, how to find the equation of a line. And we're gonna do in two ways. So equation of a line. All right, equation of a line. Okay, so there are two ways we can go about finding the equation. I will start by emphasizing one today. If I have time, I'll do the other one. The second one is the one you know. So how to find the equation using what we call the point slope form. How to find the equation of a line using what we're gonna call the point slope form. Okay, so using the point slope form. All right. The idea is that if I have a line, and based on everything you guys done, if I have a point on the line, and I know the slope, I know how to sketch the line. That's what we've done a little bit ago. So that's why I started with those problems. So the problem I started with, for example, this one, if I know the point, I know the slope, which is 4, I was able to sketch the line. So a point and a slope give us a line. So suppose I'm gonna call this line L. Let x0, y0 be a point on the line L, and let M be the slope. So I know the slope of L. So that's what I have. So I have a point here. I'm gonna call x0, y0, and I know the slope. I'm gonna get M. It means if I go by 1, the slope tells me this is M. That's the slope. Okay. I want to find the equation. The way we're going to think about it is the following. So what does it mean to find the equation? I'm going to draw any point on the line, any point. I'm going to call it xy, any point. And my goal is to give you the equation that relate x and y. So how are we going to find this equation? We say let xy be any point on the line. Be any point. Then, if I take the following, if I take y minus y0 over x minus x0, so if I take any point on the line, any point, and I compute x minus y0 over x minus x0, this should give me the slope. Okay. Now, I multiply by x minus x0 both sides. multiply by x minus x0. This will give me y minus y0 equal to m times x minus x0. This equation is called the point slope equation of a line. So this equation is called the point slope equation. And now the idea is how to use it. Equation. All right. Now let us use this equation. So I'm going to use it to find equation of the line. So one way to find equation of the line is use this form. So let's see how we're going to use it. So example. Find equation of the following line. So find the equation of the line that does the following, that passes through the point, that passes through the point 2, 4 and 6, 12. Okay, so I'm using the point slope form. All right, so how do I use the point slope form to find this? Point slope form tells me if I know the slope and I know a point, I find the equation. So to be able to use the point slope form, I need to find the slope and I need a point. So first we're going to find the slope. Okay, what's the slope? These are 2 points on the line. So sometimes I like to put them, put my data in a kind of neat table. So these are the points on the line, x and y. If x is 2, it's 4. And if x is 6, my y is 12. Okay. And so what's the slope? It's by how much y changes? 12 minus 4 divided by how much x change? 6 minus 2. It means my slope is equal to 8. 6 minus 2, it's a 4. It's equal to 2. So the slope is 2. Now a point. Okay. To apply the point slope form, I need the slope and I need a point. Now I have 2 points on this line. You can use any one you want for the point slope form. So you can use this one or that one, the one that you like the most. So a point is 2, 4. So now the equation becomes using the point slope form. Let's see how we're going to use it. That's the equation. It's y minus equal x minus. Now what goes in every spot? Right here is the slope, which is 2. Right here goes the point. Now you have 2 points. You can pick any one you want. Suppose I pick 2, 4. So that's the y is a 4 and the x is 2. That's how we use the point slope form. Once you use that, once you write it this way, now you can solve for y in terms of x. Solve for y. So you get the form that you like. So what do I mean by solve for y? It means it's going to give me y minus 4 equal. I factor out the 2. I distribute minus 4. And then what I need to do is find y. So I add 4 both sides. And I get y equal to x minus 4 plus 4, y equal to x. And that's the equation of the line. So I'm done. That's the equation of the line. So let's see what this is. Means I have a line. And I have 2 points on the line, 2, 4, and 6, 12. So 2, 4, and 2, 4, 6, and this would be 12 somewhere here. So basically, those are my 2 points. And then I have this line now. Okay, that's the line I'm interested in. That's the equation of the line. So what's the benefit of the equation? The benefit of the equation is the following. Originally, I only gave you 2 points. The benefit of the equation is now if I give you any point on the line, any point. So suppose that's a 6 here. Suppose I give you a 7 here. Right? The benefit of the equation is that to find the y coordinate, it's just I plug in 7 for x. So now this is y equal to x. So the benefit of this equation now is that if I give you the x coordinate, you can find the y coordinate immediately. So this is going to be equal to 14 without really any thought process. I take any point on the line. If this is -1, okay. To find the y coordinate, I just plug it here. This is going to give me -2. So the benefit of the equation is that once I know the line, the equation will tell me the x, y coordinate once I know the x coordinate. That's the formula for the line. All right, I'll do one more problem along this line, and then of course we quit. So find the, again, equation of the line that passes. So I'm going to give you a point through the point -2, 4, and slope. So this time I gave you the slope -2/3. Okay, I give you a minute to figure it out yourself. Use the point slope 4, and I will put here the formula for the point slope 4 because I want it to be kind of drilled in your head clearly. Okay, use this equation to figure out the equation of it. All right, you have a little bit, 1 minute to do that.
Is equation of the line just another way to say y equals mx plus b?
Exactly. But we can find it in 2 ways. Okay, and I'm emphasizing this because that's the one you guys are not familiar with most of the time. And the one you talked about, I'll talk about it next time because you are familiar with. Are you with me?
Yeah.
In calculus, we actually use this one. That's the one I use in calculus with my student because this is, but we're gonna do it in both ways. Absolutely. I want both to be understood. So it's another way of finding y equal mx plus b. So I'm going to pick one of you just to guide me, and then I'll do the math. Let me pick one. Honestly, I am picking them arbitrarily, believe me. Nick Boutrion. Okay, can you tell me what to start with? And then we will work with it together.
So you plug in y and then -4, right?
-4.
And then equals -2/3. And then be x minus a -2.
That's our starting point. And then, of course, we have to do all the simplification. So what would be your first simplification, Nick?
-2/3x times the x and the -2 on the inside right.
So if I were you, what would I do? You think what I will, do you know what I will do first?
-2 over 3 times x.
No, I
Oh,
would actually fix this. -2.
so then that would be a +2.
Right, just to make math a bit easier for me, instead of you to carrying it over and over, unless you can do it in your head, which is of course you can. All right, so now what do? Now you distribute.
So is that
Keep
all of
going.
it?
Now, what should I
Right.
add here?
Isn't that -4 over 3?
Exactly. 2/3 times 2, as we've done this several times, 2/3 times 2 is you multiply numerator, which is going to give you -4/3. All right, now if you want to solve for y, so you want to get this mx plus b form that you guys are, most of you, familiar with, what would you do? Are you with me, Nick?
Oh, sorry. What are we doing? We're just,
I want you to write it in the form y equal something.
so wouldn't it be y equals, did you subtract the 4 already? Or I mean add the 4?
No, I didn't. I'm waiting for you. I'm slow. +4. Then what would you do? You don't like this form. I don't like it either. What would you want me to do? I don't like frac. I don't like decimals also, as you guys know.
Wouldn't you do a common denominator?
Very good. Tell me what should I do?
So it'd be 4 over 3, and then whatever you do to that, it'd be like 12 over 3 on top. Yeah.
Absolutely. And then I'll get the form that you are familiar with. -4 plus 12, that's in 8, right?
Mm-hmm.
And that's to mx plus b that you guys know very well, but we're doing it not by using y equal mx plus b, that as I told you, I will do it next time, by using the point slope form. So that's another way of getting the equation of the line using the point slope form. That from my point of view, it's easier, but we will do both and you will be responsible for both. All right, that's it for today. For Thursday, as you know, your online homework, your Moodle homework is due Thursday evening. Please work on it, and I will assign very few practice problems because what we did is actually simple. So like 2 or 3, no more than that. All right. Any questions before we let go? All right. If any student have any questions about Moodle, I can stay with them online a little bit and answer their questions. Any student have questions about Moodle that I can help with?
Yeah,
I have-
the question that makes you